In this video, we're going to be using a graphing utility to find the solution set graphically instead of algebraically. So here we have two equations. Notice that they're very similar except that one, we're looking for where 6x minus 2 times the quantity x plus 2 minus 5 is less than or equal to 0. And the other one, it's that same equation but greater than or equal to 0. So let's begin by graphing. So we're going to go to our y equals, and up here we're going to type in our equation. 6x minus 2 times the quantity x plus 2 minus 5. And now we want to graph that. And we're looking for where do we get 0 for our graph? Because we're going to need that value. And it doesn't cross. If we look really close here, we see that it doesn't cross right at the 2. It's a little bit more than 2, but not quite to 3. So to find that value, we're going to calculate the 0. So in order to do that, we're going to second trace, which activates our calculating menu, and we're going to calculate the 0 of this function. Now, it's going to ask us for a left bound and a right bound. The calculator needs something on the left-hand side of where it's crossing the x-axis and something on the right-hand side of where it's crossing the x-axis in order to find the solution. So we can see that our flashing icon is to the left of our point. So we're going to hit enter, and it presents a left line. Then we're going to move over till we are above, in this case, or to the right of our intersection point here, and hit enter. Now notice that this intersection point right here that we're talking about is between our two dotted lines. And that's what we want to make sure we have happen. Once we have that, we can guess our answer. Now the reason it says guess is because when we're finding things graphically, it's just an estimate. So we're going to hit enter, and we see that we're going to get a 0 value of about 2.25. So we're going to write that down. So we're going to say x is approximately 2.25 when y is 0. So if we're trying to solve this, we look at here, our first one is for less than or equal to 0. So what does that mean? Let's take a little bit closer look at that. So remember that we want to find it when it's less than or equal to 0. Less than or equal to 0. So that means we want to know when is it below that 0 point. So when is it below that 0 point? And that happens in all of this space right here, where it's below that point. So what does that mean? That means that we are going to have a solution that goes from negative infinity all the way to 2.25. And that 2.25 is included because it's less than or equal to. Remember that it's from this point and then as far as x is going this direction, which is towards negative infinity. So what does that mean as far as our second piece? Our second piece is asking for greater than or equal to 0. So what does that mean as far as our graph is concerned? Well, what it means is that we're looking for from this point greater than 0, so above the x-axis, which we see happens from, again, this point all the way as x is increasing to positive infinity. So here we're going to go from 2.25 all the way to positive infinity. And again, a quick way to show work here would be to do a quick sketch of the graph. And simply put in our point and go this way to negative infinity is below, and from this point all the way to positive infinity is above, and then just to label our point right there as 2.25. Now if you were to solve this algebraically, you wouldn't get a 2.25. Instead you would get a 9/4. And so that would also be an acceptable answer if you converted it to a fraction as well. And so that's how you use a graphing utility to find the solution set graphically.